Part 1, Retell the Story. In the marine biology class, the professor talks about food chains and food webs, especially in relation to seafood. The professor explained that trophic relationships are about what organisms eat and what eats them. In the marine ecosystem, like other ecosystems, food is needed for matter, growth, and reproduction, and for the energy metabolic processing within the body. And also, like other ecosystems, marine ecosystems have a producer, consumer, and decomposer. Producers like eutrophic plankton make their own food. Eutrophs are consumed by heterotrophic organisms. Hetero means other, so in this case, heterotrophic means organisms that can synthesize their own food. They must rely on eutrophs for food energy. Primary consumers in the marine food chains are the plant eaters, herbivores, and the secondary consumers are both the meat eaters, carnivores, and the predators that eat both meat and plants, omnivores. A simple marine food chain then might look like this. The top of a predator, trophic level number 4 is a herring. Herring fish eat level 3. Carnivorous zooplankton. The carnivorous zooplankton eat trophic level 2, herbivorous zooplankton, and herbivorous zooplankton eat level number 1. Phytoplankton, which is a type of autotroph. In the marine food chains, energy transfer is not very efficient. Phytoplankton utilize only about 1% of the energy available from the sun. Between 70 and 90% of the energy made by procedures and or eaten by heterotrophs is used in their bodies or expelled as waste. This leaves only 10 to 30% that retained in the body biomass and available for consumer at the next highest trophic. Thus, the biomass at each trophic level is controlled by the efficiency of the energy transfer. At the lowest trophic level, animals will generally have a biomass and there will be lots of small procedures. And the highest trophic level, animals will generally have a low biomass and there will be only a few large animals. A food web is more complex than a food chain. And then there are gigantic animals like whale, sharks, and baleen whales that are herbivores and only eat plankton. The implication of the trophic level for the fish we can eat this 88%, or the fish we can catch, the fish with fins. 8% are shellfish and 4% are crustaceans. Fish caught in the open ocean, such as a tuna, are the high-level predator on an inefficient food chain. Fish caught in the coastal areas, such as cod, herring, and haddock, are the top end of the shorter, more efficient food chains. This is because there are the high density of phytoplankton. In upswelling areas of the west coast of America and Africa, the fish are even healthier. Here are the small, very efficient food chains, and the fish are small, fast-growing, eat lots of phytoplankton, and travel in the distant schools. Two examples of such fish are anchovies and sardines. Part 2. In the American historical class, the professor talks about how women have often been left out of the U.S. history textbooks. History has ignored women's contribution because they haven't been president or top military leaders. But now, a perspective called woman-centered history is looking at the important roles women have played behind the scene, like a forming organization and fighting for rights. The professor gives Jane Addams as an example. She founded House for Poor People in Chicago and was an original member of an American Civil Liberties Union, or ACLU. She lobbied the government for the rights of workers and women, which paid off in the 1920s. When the woman received the right to vote in 1931, she became the first American woman to win the Nobel Peace Prize. Woman-centered history sees gender as important in history in its difference from the past ways of studying women. This perspective is different from the past model of studying women in U.S. history. One of the first models is called the contribution approach, which considers that men played the leading historical roles but demonstrated that women were vital supporting actresses. At every landmark historical event, while this was certainly true that the contribution approach has been criticized because it highlights only the bravest and the brightest women. And it also neglects the social role of women in every family life. A second historical model is called the victim approach, which emphasizes how men have obsessed women throughout history. It also tends toward emotionalism, overly dramatizing women's plight. Critics charge that under the victim approach, the only women who stand out are unusual ones, such as the famous Salem witches of the 17th century. Woman-centered history asks, what have women done? In one sense, it still gives only a partial picture, because it examines history from only one perspective, but in another sense, it gives a fairer and a more complete portrait of U.S. woman past than the previous two models. Historian Gerda Lerner says, woman-centered history tells how women have survived and contributed in a male world on their own terms. Ms. Lerner claims that woman-centered history best portrays the balance of the interaction between women's oppression and women's power. The professor notes, the feminist scholars keep studying the story of U.S. women, more new approaches likely to develop. For example, there are still several subcategories of a woman history to consider, such as labor history, social status, and the history of women in minority cultures, and so on. There are also class divisions, race division, ethnic division, and religious division. Finally, there is the history of a woman interaction with other women, not just with a man. Part 3. In the university science lecture, the professor talks about island biogeography, which is the study how plants and animals are found on island. The professor focused on the MacArthur and Wilson's 1967 theory of island biogeography. This theory explained that the number of species on an island is determined by two main processes, immigration and extinction. The professor used Krakatoa as an example. After a volcanic eruption in 1883 killed all the life on the Krakatoa, 34 bird species arrived between 1883 and 1933, but 5 went extinct. From 1933 to 1985, 40 more species arrived and 8 went extinct. As the theory predicts, the rate of immigration declines as the island alveoli matures. As the equilibrium approaches, the north continues, but the total number of different species level off. When the overall bird population finally reaches a mature equilibrium, when the arrival rate of new species balances the extinction rate of unsuccessful species, the island may host everywhere from only a few almost all those 100 mainland species, depending on the island overall receptivity. Several factors affect how many species live on island. Bigger island like Papua New Guinea, which has almost 800 bird species, can support more species than smaller island like Bali, which has about 300 species. Island with a different habitat, forests, grasslands, and wetlands can support more species. For example, Tonga have a 75 bird species because it has both mountains and lowlands. The Tuamotus, with fewer habitats, only 57 bird species. Islands closer to mainland have more species because it is easier for species to reach them. The Lucia archipelago, close to New Guinea, has more bird species than the Hawaiian Islands, which are farther from the mainland. The professor also explained that these principles apply to other isolated areas like lakes, mountaintops, and national parks. Understanding island biogeography helps in conserving species in this associated area. For example, knowing what species like wolves and California condors need helps in their reintroduction and management in national park.